evening, everybody, and welcome to Suffolk Developers Talk with Adam Cable, who is you're not an Innovation Martlesham resident anymore, but you are a local development house, and Adam will tell you more about himself in a minute. So the talk this evening is called Turbocharging the Performance of Your LAMP Stack, and is, as I say, a Suffolk Developers Talk, but Suffolk Developers currently sits under a kind of umbrella organisation called the ISTN, the Ipswich and Suffolk Tech Network. And we have loads of different talks. So we have some all the way through from kind of small business education. The next event on I think that's Thursday is raising startup capital, so that fits under the small business talks, and we go all the way through. We have, by Christmas, we're hoping to have about 10 hours of education. So we've got Suffolk Developers, Sync-Ips, which again we've got a series of talks called the Matrix series, which is around 5G in the cloud. We've got another one which is around cyber resilience. Then we've then got the small business education. We have also got AWS users, Agile, Azure, OWASP, which is more cybersecurity. There's loads of others, and we've got a couple of pub events as well. So we're kind of bringing everybody together. We're hoping that if you visit the istn.org.uk, I'll pop the website into the link as the talk goes on, that you should find something to float your boat. That's very much how we're trying to pitch it. And so this evening, as we said, technical Suffolk Developers will pass you over to Adam. He'll explain to you everything around questions and how he wants it to run. I'll let anyone in the background, so I will pass over to Adam. Here we go.
Brilliant. Thank you very much, Sam. Welcome, everyone. I think the last time I did a Suffolk Developers talk, I did it in real life, where people were there and people could ask questions and you could see whether people were still awake or not. So I'm just going to base my talk on the assumption that everyone is still awake, but please butt in if you feel like you're about to drift off. So I guess really introductions. My name's Adam Cable. I've been working in IT for about 20 years now. I started off at BT and then moved to London to work for MoneySavingExpert.com, which is a big financial services institution. I guess everyone will recognize the name Martin Lewis from the television and radio and all that type of stuff. So I spent about 5 or 6 years there working and building price comparison sites. And then about 7 or 8 years ago, left there to do similar stuff, but by myself. And so over that time, I've always been working really in web technologies. And so I guess really the talk today is a combination of stuff that I've learned along the way and stuff that I've messed up and made improvements with. I'm going to quickly share my screen, and hopefully someone will be able to shout to say that they can see everything okay, which is useful to, if not, you'll just be seeing me and hearing me without any slides there. So Sam's given me the thumbs up. Thank you very much. And so I created these slides about a month ago, and I returned to them yesterday and did a quick run through of the presentation and realized that I missed loads of stuff off. So I've added some extra slides in today to take you through. So let's get started. In terms of how in turbocharging your LAMP stack, I'm assuming that maybe half of you are either web developers or system administrators or deal with web technologies in some way. And as part of that role, your job really is to make sure that the website is fast and responsive, because A, your users will be happy, and B, if you're looking to make money from the website, that will definitely help. And so when you're looking at making your website faster, the first thing you need to do is to find out where you are today, i.e. I'm going to measure my website, and if I make some changes, are they going to make my website faster or not? And so we need to use some tools really to help us to measure that information. And very crudely, lots of people start off with this software called Apache Benchmark, AB, and I'm going to take you through some various software and ideas and tricks, but I guess maybe quite heavily focused on the MySQL and PHP side of things, just because there are some really cool things you can do around that area. But anyway, let me just take you through this first slide. So our homepage is at www.adsar.co.uk, and we are running this software directly on our server. And so we run Apache Benchmark, we want to run it for a minute, and we want to pretend like there's 10 people desperately wanting to access our website at the same time. So we have a concurrency of 10, we run the command, and across that minute, it tries to collate some stats for us. And those stats are then shown in this nice little output here. So we can see that it's determined that we're using Apache 2.2, that our document is about 6K in size. It's run for 60 seconds. And you know what? We've made just shy of 20,000 requests across a minute, which is really cool. But you would expect that because you're running it directly on your server, and the page that it's hitting is just a very basic HTML page. There's nothing more than that. And so with that, you can get over 300 requests per second on a really cheap instance. What's more interesting though is maybe these numbers further on. So you can see that 50% of users or requests were responded to within 28 milliseconds. And then you can see here the longest request was just shy of 1/10 of a second. And so if this was real world, I think we'd be mega happy, but this is directly on the server. And Apache Benchmark, you can run from other servers, but there's maybe better software out there. So we tend to use a nice product called loader.io, and we're always quite keen to use free tiers of stuff, because once you get sucked in, it's very easy to spend lots and lots of money on these products. But actually, loader.io is very good in its free form. But what this then gives us is a view in the real world. So this is pretending that someone from another location other than where your server is making this request. And as you can see, the numbers are a lot different here. So we're running exactly the same test. So we want 10 concurrent clients, run it over a minute. And actually here we can see the response time is just over 300 milliseconds. So actually, I think it's actually really good. But again, this is a very basic web page. What the graph can give you, though, is some interesting stats across time. So the green line here is just the 10 concurrent clients, but the blue line here is your response time. And so you can see it stays fairly static over time, which is really good. But one of the tests perhaps that you might want to do is to look at what happens over time. So for instance, you could run this for a whole hour and see what happens, because what some people find is your server runs really well, and then maybe 15 minutes into this test, either your logs fill up, or you have memory exhaustion, or you have problems with your code that causes your website to behave poorly. And it's this type of testing that can maybe help you to dig deeper and to find those types of issues. So loader.io is a really cool little product that we use quite a lot, especially when we're testing new stuff that we're developing. As well as testing stuff for now, I think it's also good to have a broader picture of your performance of your website. So we use Pingdom, and actually it's quite expensive product, but we use it for two reasons. One, you can see your performance of your website over weeks and months and days, and however far you want to go. And also it's very good at alerting you when things go wrong. So if you're looking after websites that bring in a good amount of revenue, having downtime is not a good thing. But actually what you can see in this graph here is that the endpoint that it was testing is really stable. And typically for Pingdom, you'll get requests across the whole of Europe. So this isn't just London to London type connectivity. This might be from Paris or from other countries too. So you can just see, you know, how your website is performing. As well as that, we utilize a piece of software called Xavix, and Xavix monitors your server's health. And so in these graphs here, we've actually got 4 servers that we're monitoring at the same time. And you can see over various days here that our CPU utilization differs between our different boxes. And this is quite useful sometimes to identify either a poorly behaving server, or if someone's attacking your machine, or it's getting spikes, or there's things that you need to take care of. But Xavix is really good as well at telling you if your disk space is low, or if we've got connectivity issues. So we'd really recommend looking at loader.io, Pingdom, and Xavix, which takes a little bit of installing to get configured and working correctly. So that's the starting point. Where are we today? What's our performance like? And then you have all the fun of, it could be a day or a week or a month type of work to take you forward. And how do I improve the performance of our website? And really, from our perspective, there's 4 main areas. So web layer, so web technologies, what can you do in your code that the browser consumes? Your database layer, so what can you do in terms of optimizing your database performance? your application code, so in this instance, PHP, and then finally, what can you do with your servers to make them better? So after each of these sections, I'll stop, and if people have questions, then feel free to ask. And I use a standing desk, so apologies if I move about too much. I hope not to lose you. Anyway, here we go. The first thing that so we're going to talk about web layer optimization here, and the number one thing you can do is to make sure that your content is compressed. You'll be surprised at the number of websites out there where their HTML, their JavaScript, and their CSS files aren't compressed. And this can really dramatically improve the performance of your website with just really a few lines of code change, and it has no impact across your server estate. So for example, here, we're just using, when you press F12 in your browser, you can get your nice debug window open. We're just using the network tab here. And you can see we've got a CSS file here. We just called it main.css, and it's 400 kilobytes in size. And typically you would send that whole data packet across, but because we've turned on gzip, then we're doing about 15% of its original size. So we can send that file within 1/10 of a second. You can see here how quickly I downloaded it. So if you don't have compression on, if you don't know how to test for it, here's a very basic configuration file that you can use for Apache. So what we're saying at the top here is that we want our HTML and our JSON type files to be cached by the browser for 5 minutes, because we're not expecting anything to change within this time. And this little block here turns on the deflate filter, which is maybe not the right name for it because it wouldn't be the way I would describe it. But if you've got JavaScript or CSS, then we want to compress it. And we compress that file and it just goes across the wire compressed. And when it arrives at your browser, it decompresses it and reads it as it is intended. So compression is your big win. It's the number one thing you should look at if you've not done anything before in terms of looking at improving your performance of your website. Once you've done that, the next stage really is to look at a process called minification. And so this can take your CSS and your JavaScript files, and it can re-engineer what you've typed in to make it more efficient. So it might combine CSS rules together. It may get rid of semicolons that you don't need, or other declarations within your CSS file. And so you can see here the same example that I showed earlier. We've got a 400K file, but we've run it through this CSS Nano software, and it's effectively shrunk the file in half without compression. So you're not losing anything. It's just rewriting your CSS scripts. And this has two benefits, right? One, the file is smaller, so it's quicker to go across the wire. And also it's quicker for your browser to read and consume. So the amount of time it takes for Chrome or Firefox or whatever you use to consume that CSS and to convert it into what it needs to know is quicker. And again, you can do exactly the same process with JavaScript. So we use some software called Uglify Js. We use a few flags here that I'm sure you can Google and find out exactly what they do. But again, the change in the file size is quite dramatic. So here from 650K to 260K, and nothing changes. The end user experience is the same. And once you've minified stuff, you can then still run it using compression, and everyone wins. There's maybe some new technologies that you haven't maybe used before or heard of that can also help with improving the responsiveness of your website. And here's a couple that you may have seen or read about before, but not really too sure what they do. Anyway, I'll quickly describe them. The first one is Preload, and this is a very simple HTML tag that you chuck into the header of your page, and it tells the browser, whatever you're doing, I want you to download this file now, and I want you to download it at the highest priority that you've got, because you will definitely need this file on this page. So it's a priority flag, effectively. You're telling the browser to download that file before it does anything else, if it can, and then use that within the file. So, people might put fonts in there or CSS files, but it's just a very big hint to the browser that it needs to download that file. The second one is pre-connect. And so it's a subtly different idea here. What you're saying is somewhere in the page or somewhere in our scripts, we're expecting you to have to go to this domain to download some information. And because we know that, we're asking you to connect to that domain, i.e. do DNS resolution, do a TLS handshake and connect ready to make your request later on. So it might be half a second down the line, but it's already done that DNS handshake, so you don't need to do that, you don't get the delays. So preload and pre-connect are really interesting tags that maybe only come along with the last few years that can really help to change the performance of your website. Other technologies that are really useful on the front end is HTTP2. So HTTP2 was relaunched maybe 3 or 4 years ago now, and it was, you know, a big step change from HTTP 1.1. So as you can see in the picture here, there's a couple of things that HTTP2 can give you. It gives you multiplexing, so across a single socket, it will chuck you loads of data at the same time. So in HTTP 1.1, you say, can I have the HTML? Can I have your CSS file? Can I have your image? Whereas HTTP2, you can just do that over a single socket, and it just makes it a lot faster. It compresses the headers. So in HTTP 1.1, you don't get that. So it gives you header compression. And again, that can help speed the communication between your browser and the server that it connects to. But for us, the big win that you can have is to use Cloudflare. I don't know if people have got the ability to show their hands or raise their hands, but does anyone use Cloudflare at the moment in their area? Anyone at all? No? Okay. So yeah, Cloudflare, if you've not heard of them, they're a massive technology company now. I think they launched about 6 or 7 years ago, and their idea was to provide a free-to-use web application firewall and DDoS protection. And so we use this now for every single site that we release. Nearly, I think 99% of our sites we use their free plan, because that is good enough for nearly everything that we do. So the things that it gives you by default is it gives you HTTP2, it gives you free SSL connectivity. Then you've got these other cool things. So you've got their software called Polish, which automatically shrinks the size of all your images on your web page. It does auto minification, so it looks at your content of your site and it will minify the files automatically and store them at its edge. So when the next person requests them, you get the files in their shrunk size and quickly too. And for us, especially, the one thing that you get for free is you get load balancers. So you can have your website deployed on 3, 4, 5, however many sites you want, and it will do load balancing for you for free. And so, yeah, Cloudflare is a really great product to use. And for us, the greatest benefit that we have is that it hides the IP address of your server. So when you use Cloudflare, people cannot tell where your server is located, and therefore it helps to restrict the opportunity for people to try and break into your server, which we think is really good. Some other technologies that, again, this one's a little bit interesting, right? Because if you've not used HTTP2 push before, it feels like a weird technology, and Chrome may be stopping to use this, may have decided to stop use this soon. But anyway, I'm going to talk about it because I think it's great. What HTTP2 does, or HTTP2 push does, is it sends files to your browser without the browser even asking for it. So say, for example, you go to a website. What HTTP2 push can do is it says, well, you've come to our website, brilliant. We're going to give you all the images we need. We're going to give you the CSS and the JavaScript without the browser even asking for it. And so this can dramatically improve the performance of your website. So here we have an example, exactly the same website, but the first one here, we haven't got HTTP2 push turned on. So you can see this JavaScript file that we've called Mega. I don't know why we use these silly names, but we just find them quite useful. This has all of our JavaScript into a single file. And you can see within the waterfall process that the actual time taken to download the mega.js file was just over 400 milliseconds. So you have, the DNS lookup, the handshake, the waiting for the request, the download of the request, and the parsing of the file. It takes 450 milliseconds in this example. Instead, when you turn on server push, then if you see the mega.js file here, you can see that the initiator was push, and here it took 9 milliseconds because the browser said, right, I need mega.js, and he went, oh, I've already got it, I know all about it. And this can really help to speed up a website. You have to be a bit careful not to push too much stuff because you can saturate a user's connection, but that can dramatically improve the responsiveness of your website. Other things to look at, these are maybe smaller type optimizations that maybe won't give you the biggest wins, but again, quite useful to look through, is to use, you can instrument your coverage, i.e. what you can do is look at all your JavaScript and CSS files, load up some web pages and determine how much of that file is actually necessary for the user to view that page. And so just an example, I loaded up the BBC News homepage, and you can see in this coverage window, we've got quite a few different CSS and JavaScript files used. And then on the right-hand side, you get this nice little visual. The red is the amount of content in that file that isn't used. And so this can sometimes give you ideas on optimization. So for example, if I carry on through, you can see there's lots of these CSS declarations that aren't used on this page. And that might be fine, they might be used on other areas, but if you've got a page that's mega heavy, you might be able to identify chunks of your CSS file that you can just put away and leave to be served just on a niche page that not everyone really cares about. That was my quick rant on web technologies. Shall I quickly see if we've got any questions or any chat about HTTP or anything around that?
Yeah, there's definitely some questions in here. Apache JMeter question mark?
Yep, so you can use JMeter to do very similar type of testing if you want to. Yeah, people tend to use Apache Benchmark just because it's easier and maybe it's being used more often. I don't know that these are questions. I think a lot of them end in exclamation marks. So I think they're just adding value. So we've got one here though that does say preloading fonts always gives longer for adverts to show, mostly to delivery adverts, presumably. Guys, I don't know if that was contextual to something that Adam was talking about. Adam, can you see those comments? I can see the comments, yeah, from Martin. Yeah, I can see those.
If there's anything you want to add to that, or Martin's there, if you've got anything you want to add as well, let us know.
I think what Martin was saying is that a lot of the time these types of technologies are used to show more ads to people, and if you can show more ads or quicker ads, then there'll be one company out there very, very happy with that.
So what's your take on SolarWinds then, since you were saying that one of their products is a good one to have?
So we were using Pingdom before it was purchased by SolarWinds. So
right.
It was
because they've had a little bit of trouble recently. Haven't they? To put it mildly.
They have. But we don't have a problem with them connecting to our site one time a minute and just seeing what the response time is. I think there are definitely other SolarWinds products that are more involved, but we would always stay away from there. What was the interesting comment you made, Martin, around preloading fonts? Is there's some new CSS declarations on fonts that you can do to decide whether to show content before the font is downloaded, and so there may be times where you're just happy for the user to see an unstyled font and then to get a better version later on. So yeah, there's definitely some new declarations around fonts that can help you in terms of performance there. Yeah.
Adobe, of course, abandoned the idea of the multi-purpose fonts years ago, so they would have been perfect for the web that we have now, but of course they were the wrong thing at the wrong time then. Did you have any thought on decompression? Because the advantage for a server of compressing files is that it's good for them, but it moves the decompression load out to the edge of the network, and all the people who are watching, all their computers are busy decompressing.
I think the major assumption is it's quicker to decompress than it is to send that full fat file over the wire, and then yeah, you're more than happy to use someone else's CPU because it doesn't cost you anything, right?
I was just thinking in terms of sustainability, which is a hot topic at the moment. I'm not so sure that's good in terms of sustainability.
I think it's just the default, to be honest, nowadays as well, because it makes things faster. So hopefully people can read it and then turn their phone off and save some battery life or whatever they're using.
Mm-hmm.
Do we have any more comments, Sam, as well? Or I can see one more around minification or compression with browser compatibility. I think nowadays people either use the latest version of Edge or Firefox or Chrome, and they have no issues whatsoever with minification or compression. And if you're using one of the standard JavaScript minification tools, then it's been used by so many people that there really isn't any issues with using that. Cool. I'll carry on.
I'm chatting away and I'm on mute. So that as well, guys. Sorry.
I could see your lips move. I was just trying to tell exactly what you were saying. But anyway, we'll carry on now. Now we've talked about that. We've had a quick fire through a web layer. We're going to quickly look at database side of things. So in the LAMP stack, traditionally you would use MySQL, or perhaps you'd use a plugin replacement like MariaDB. But I guess really from our perspective, the ways that you make your website faster is to make your database respond quicker. And so traditionally, the advice is to turn on a process called slow query log, and you can define it to tell you when a query takes longer than X number of seconds or X number of milliseconds, and it'll get logs, and then later on in the day you can review that log and try and speed up those queries. Now, we like that idea, but in the real world, it doesn't help too much, because typically they show those queries that maybe only happen once an hour, and they're sort of your outliers. And so our view on optimization is to try and look at the queries that get run most often and try and improve the performance of those. And so once you've identified those queries, typically you'd use an explain plan. But more recently, we've been starting to use MySQL Workbench, really just because it shows a visual version of the explain plan, which is one of the things that really has been lacking in the MySQL world. So if you can see my screen on the right hand side here, this is just showing me very basically, I've got a quite simple SQL statement here, and we get the nice green boxes that tell you that things are using unique key lookups or foreign keys, and then you get this red block here that tells you, hey, we're using a full table scan here, and we're looking over 179,000 rows. No wonder your query is slow. And these types of techniques will help you to identify and to speed up, at least to try and rewrite your queries to try and make them more performant, because you really don't want your database to have to read 180,000 rows each time it runs this query. But if that query only gets run once an hour and you cache it, it's not so much of a big deal. So what we use is there's a great toolkit called Pacona Toolkit, and they have about 50 or 60 different little bits of software that can help you to improve your MySQL database. They're MySQL consultants, and they're experts in MySQL technologies. So instead of looking at the slow query log, what we advise people to do is to look at the general performance of your database. And this command here looks complicated, but really isn't. The first bit here up to the pipe character is telling it that you want to sniff your traffic on your MySQL server, and you just want to sniff every single piece of traffic that happens that connects to your MySQL server. So we might look at that for maybe a minute or an hour. Once it's sniffed all the traffic, you want it to pipe it into this PT query digest software. And what I've asked for here is to tell me the 20 most interesting queries to look at. And this really is our foundation for improving the performance of your database. So once you finish running your software, you get this wonderful display of queries. And these queries are ranked by not really the response time, but really the impact that it has on your database. So ignore the first one. The second row in this result set is an insert statement. And you can see here that there were 600 calls to this statement within that minute. And it took 10% of the time of everything running on that database. So actually this had quite a big impact. 10% of your workload on your database server was just this one query. So why not try and improve the performance of your queries that get run most often? But if you want long running or slow queries, you can see here in row number 6, we've got this SQL statement running here that each request takes over 3 seconds, and that was run 6 times. And so maybe that is the area that you need to focus at too. You get this nice little header row, but then after that, you get a breakdown of every single query that it's looked at. And you can see here, this is the query that took over 3 seconds. You can see its total execution time was 19 seconds. It was always about 3 seconds in duration. And it shows you an idea of the query that you've run and gives you some statements that you can execute to get an understanding of the tables involved. So these are great indicators to show you where you should maybe look at adding keys in, or rewriting your queries, or restructuring your data. I think the question is this freeware? It is free. The Pacona Toolkit is all free. Is there an equivalent graphical tool for Oracle or MS SQL? I don't know. We don't tend to use those technologies, but I'm sure there's something that you can use online or within the software. So this is a great way to hone in on those queries that you need to rewrite to improve your general health of your database server as well. And talking about health, the biggest area that you can work at in terms of improving your MySQL instance is to make sure that it's configured correctly. And the number one thing to look at is your buffer pool. So in MySQL terms, the buffer pool holds your data up to a certain limit, so typically defined in gigabytes or megabytes. And this data is a cache that's held in memory. So if in the ideal world, in your dream world, you store all the data that you own in memory so that all your queries run lightning fast. If you don't do that, then the MySQL server has to go to disk and to read all that data in and then use it to process your queries. So we use MySQL Tuner, again, a free piece of software. That's how you download it and execute it. But there's this number here on the bottom row is really interesting. So we ran this against one of our servers, and you can see that our buffer pool size is set at 128 meg, but the data that we hold in that server is 2 gig. So there's never going to be a time when the data in your database is fully stored in RAM. So you're always going to have that time when you need to use I/O to give you the results that you're looking for. And this can really impact the performance of your MySQL server. So the dream here is to improve or increase your buffer pool to make sure that your data is always smaller than your buffer pool. And obviously there's 2 ways to do that. One, if you've got enough RAM, increase your buffer pool. Or number 2, you need to shrink the amount of data that you're holding in your database. So yeah, here, the dream is to have your buffer pool greater than your data size, and to make sure that your MySQL server is configured to run as a dedicated server. If it is, it will set all your memory parameters automatically for you. This SQL statement here will help you to identify any large tables in your database schemas. So they're maybe the ones that you can target to either reduce what you're storing, or maybe looking at making sure that your data types are correct. So your storage reduces just because you don't have massive data types for small bits of data. So that's quite a useful SQL statement to run to help you to optimize your tables. Also, in terms of optimization, if you have some tables where you have a big increase in data size that's only happened over a recent time, then the MySQL server may not know that that data has changed fundamentally. And so periodically, so for example, for us once a month, we'll run an optimized table script across our whole database environment. And this gives MySQL the hint that it needs to have another look at your table and to make sure that it knows how your data is distributed. So when SQL queries are run, then it knows how to join tables together most efficiently. Again, this is our SQL statement that we run that will give you the optimized table commands that you just execute, and it'll just do it across every table in your server, and it can do it nice and quickly. The final comment really to make around MySQL databases is that third normal form is not always the most performant way. So I remember when I was at uni, we always taught Codd's law and made sure that our database is third normal form, and that's brilliant for storage. It optimizes the storage that you have. But there are some times where you just have to denormalize your data to make sure that the MySQL server can read it faster for you. There's no point trying to take 10 seconds to run a query because people just won't wait that long. And so sometimes you do have to denormalize your data, but then also think about how you're going to keep that data accurate and up to date. I have another question mark here, which means it's time to ask if there's any questions around MySQL database optimization. Do you have any more questions other than the ones we've had in the chat already? No? That's fine. We'll carry on. We've got 2 more sections to talk through anyway, and I'll keep on whittling through. Thanks, Lee. The next or third area to look at is your application code. So I've written in PHP for the last 20 years, and the reason why I do that is because the language is really simple, and it means that I feel like I'm really, really good at writing code, when in fact I'm just keeping things very simple, and you don't have to care too much about what you're doing. But when you're writing PHP code, because it is so simple to do, sometimes you can write your code in a not particularly performant way. And so you can have code reviews and do all that jazz where you get people to review your code, but sometimes you just want the computer to tell you what you're doing wrong. And there's some great tools out there to help you. One of the main ones that we use is a piece of software called Xdebug. And you can hook that into your server and you can tell it that when I run a particular URL or execute a particular file, I want you just to store everything that's happened. And so, for example, here I have run Xdebug against a particular PHP file. And the results tell you how long each function took. And I guess you'd maybe be used to running this in maybe more client-side software or stuff that you've built in Windows environments. And maybe you don't always get this type of information when running on a server, but this is really useful. You can see here that we're calling a function 3 times, and these numbers here are 10 times too large, but so we've spent, maybe about 20 milliseconds here, or 200 milliseconds running these functions. And again, it can help you to identify the functions that you need to optimize, either with the calls to your database that you're making or with the software that's written within that function. But Xdebug is really useful too, especially if you've got a slow loading page and you want to identify why it's slow loading. It will tell you which functions inside of your PHP code are running slowly. That's fine when you're running just a single file and you just want to get a view on that. But when you're running stuff in production, it's better to use other software than Xdebug. And we typically use a product called tideways.io. It's a pay-for product, but it's well worth the investment. And this is a quick screen grabber. Actually, it might have been an email they sent, just telling us about performance of a specific page across a week. So you can see here the performance of the page over time. You can see our error rate. You can see the maximum amount of memory that any of the scripts ran at any point. So across a web transaction, using over a gig of data in memory is not great, I wouldn't suggest, but there may be times when you need to do that. And again, you can, very similar to the Query Digest software, it shows you your impactful transactions, i.e. which are the ones that get a lot of requests or the ones that run slowly. And sometimes they are the same thing. So you get lots of traffic on a slow page and they can have a big impact. So again, this is really good at showing you performance over time, just within the server. So you're negating any network traffic or user issues. You're just looking specifically with inside that server executing. And again, that's quite good when you run it over multiple servers, because there might be one server that's running slower than another. With inside Tideways as well, what we find really interesting is you can tag parts of your code. So when you click into a piece of, a specific file that you're using, you can see how long this ran just over 90 seconds. And you can see here that this SQL statement was the majority of the time. And so that's maybe the area to look at, but also we've tagged some extra functions or groups of functions together, so we can just see how portions of that page or portions of your code, what time it took, and whether it was doing any other calls to anything else. So these types of call graphs are really quite interesting when you're going deep inside your PHP code. In terms of improving the performance of your PHP code, though, caching is always your big win. So whether you're caching the results of your database calls, whether you're caching the results of any computations or caching your full page, these are the things that can really help the performance of your website. And we typically use Memcache just because it's a very simple piece of software that runs really, really well. There's some options here that if you're using Memcache, you might want to turn on. The biggest one is that by default, you can only store an object up to a meg in size. So this little flag here lets you store up to 15 meg, which is quite useful when you're storing large blocks of information. Martin's question is quite interesting about what's the overhead of using these tools. So when you're using something like Tideways, you can define a sample rate. So you might want to say only 10% of transactions will hook into that Tideways software for monitoring. So you can bring that down depending on the traffic levels or how much you're looking to do. And also, I don't think that the overhead is that high. We've not really seen any issues. I couldn't tell whether it was running or not. That's just from personal observation, really. But yeah, I couldn't really see any difference. If you're using Memcache in PHP, there's two classes. So there's like two competing ideas. And we found the Memcache D class to be vastly superior in terms of performance than Memcache. So there's 2 implementations. So yeah, hopefully that might help you, because it was significantly faster to use Memcache versus Memcache. When you're using caching type technologies, then it's always useful to know how much of your website you're caching. So there's some, some scripts that you can download to give you views on that. So you can see here that when we were running this software, 90% of the database calls that we were making were being cached. So, 9 out of 10, I think is pretty good going. So you can see, over 40 requests per second were being cached. And then you'll always have outliers where you're doing something different. So it's always good to check how much you're caching and what you're doing. In terms of PHP code, there's 2 areas that I just want to touch on. The first one is a function that no one ever talks about, and this is fast CGI finish request. And if you do PHP code, then typically your work processes look at what the person's requested, do some work, maybe we'll log to see so that we can record that the user's come to this page, we'll do some extra stuff, and then we'll send the request back to the user. But actually those last few bits at the bottom, logging and any other type of transactions you're doing, the user doesn't care about. You've already got the result. So this function tells the browser that you finish and pushes the request or the response back to the user. But the PHP code carries on running in the background and will do your logging and other things afterwards. So you might be able to save 1/10 or 2/10 of a second by just calling this function before any logging that you do. The other one that's really interesting is flushing. So if you've got a page, for example, that takes 5 seconds to load, the first part of the HTML file that you send to the browser will be, these are the CSS and JavaScript files that we need. And that bit doesn't typically take too long. So if you know your page is going to take 5 seconds to load, what flushing does is it gives the browser an early view of what you've created so far. So you can actually pass that first bit of HTML content to the browser, and it can start to read it and identify the extra files that it needs to download. So a very crude example here with the 5-second process. On the left-hand side, we've got a waterfall here of the request coming in. We wait 5 seconds, and then all the files get downloaded afterwards. And on the right-hand side, we've got this 5-second process, but after we've generated the header, we've flushed the page. So after we've done the flush, the browser has already started to identify these files here to download. So by the time the page is finished, we've already got 1/10 or 2 in our hands in terms of speed improvement. So flushing can sometimes help, especially if you've got slow creating web pages. And I think I've got another question mark. Is there any questions about PHP code? Again, that was a whirlwind tour of performance of PHP. Any questions around that area? No? Cool.
You saw the question that's in there, but that was from before.
Yep.
Yeah,
I think that's fine. Good. Okay, we'll carry on. And then the final area, do you know what? This is really interesting for us because in the past, we've never cared really what our servers are like. And so we have spun up the cheapest instance we can find, deployed our code, and said that's good enough. But more recently, over the last couple of years, we've been working on projects that are database heavy, that require a lot of computational work before a result gets given to the user. And therefore, every performance improvement we can do really helps. But from all the three areas I've talked about already, the servers is actually where we've found the biggest improvement. And I'll tell you why. If you're running PHP, you may realize that you're maybe running in an old version of PHP. And there was a big step jump between PHP 5 and PHP 7 where performance has really gone up. And so if we take the base figure for PHP 5.6 versus PHP 8, for a WordPress instance, you're seeing double the requests per second that the same similar server can cope with. So all you're doing is replacing the PHP compiler and you get double the speed for nothing, for free. It's brilliant as long as your code supports PHP 8. I'm just going to answer a couple of questions. So do servers utilize the GPU for processing nowadays? Not that I've seen, not in terms of PHP processing, only if you're doing some clever stuff around graphics and other things where maybe the GPU can get involved. or if you've got any specific code that maybe utilizes that specifically, but no, it's pure CPU stuff. And then from Simon, is there an optimal place to flush? I've never been asked that before, but that's quite an interesting question. But yes, I would say the best places really are to flush before you're doing any intense computation work, or after your head. If you've produced your header, then that is really the best time to do your flush. And yeah, Martin, you're right. The servers really don't bother with GPUs in terms of good specs graphics, because if you ever try and VNC to a server, you'll see how poor the graphics cards are. Anyway, so PHP 8 gives you a massive performance boost as opposed to PHP 5.6. The other areas that you can look at are opcache. So the way that PHP works is you write your PHP code, and then it then gets converted into what's known as opcache or opcode, and this is what gets executed. So that process of going from your code to an opcode, there is that compilation process. So if you turn on opcache, then it just does that piece of work behind the scenes before the file gets loaded. Or it will cache the results of that. We have a thing called preloading, where you can just say, here's on my PHP script, I want you to just pre-compile it and just get it ready for everyone. And then more recently in PHP 8, we have a just-in-time compiler, where as your PHP code is running, it will identify if there's any areas where it can change your code into sort of raw machine code and make any portions of your code faster on the fly. And so especially if you're doing mathematical type operations, that's where the JIT can come into play. But that's quite early days, and not many people are taking advantage of it yet. But if you are using opcache or preloading, then it's also quite interesting to see, to make sure that your files are being cached and used appropriately. So you can see here, for example, this file's been cached and it's been executed 10,000 times on the server, and so it hasn't had to do 10,000 times worth of compilation. So caching in the PHP world for opcodes is really quite useful. On the server side of things, more recently, we've been making sure that a piece of software called tuned is turned on. So it's a daemon to make sure that your server is always highly tuned or configured as appropriate. And so you can install the software and you get different profiles. And so depending on what you're trying to use the machine for, you can do, power saving mode or default, but the mode that we've turned on for all our servers now is throughput performance. So this makes sure that your machine is always ready to respond to requests in its most optimal state. And so we've turned that on across our servers, but we've never measured it. So it might be one of those misnomers that really doesn't do much, but we feel like we've done something and made sure that it works. One thing's really interesting. So a couple of years ago, there was a big push in terms of extended verification SSL or EV-SSL. And in your web browser, you would know that you were on an EV-SSL site because you had a nice green padlock in the browser bar. Now, Chrome and Firefox have started to go away from that idea of a green padlock, but people have realized that turning on extended verification SSL is really slow. So for example, here, Compare the Market downgraded their SSL certificate from EV just to normal, and they saved 400 milliseconds on every request on 4G connections. So sometimes you have to review everything that you're doing to help improve the performance. And also from our perspective, our idea of architecture has changed more recently. So this would be your traditional architecture where you have web servers on the front and you can scale horizontally depending on how much traffic you get through. You'll then have application server, so typically running PHP FPM, and then you'd have a database in the middle that stores all your mission critical data. And what we've found for some of the projects we've been working on recently, that actually the network traffic between these machines can actually significantly increase your performance. And so what we're doing nowadays for some of our projects is to have nodes that are self-contained. So within that machine, it has your web server, your application server, and your database server together. So it just talks to itself for everything, and it becomes, these become then just little units of computing that you can scale up, but also making sure that your data is still stored somewhere appropriately after that. In terms of servers, then we've sort of gone from or tried to take a look at things between cloud servers or cloud servers with high performance CPUs or dedicated machines. So for example, we use DigitalOcean for lots of our servers because they're really cheap and they have automatic backups and all this great stuff, or Vultr if you're maybe looking, or UpCloud if you're looking at more high performance CPU type work. And then we've started to compare between Intel, AMD and ARM processors just to try and get either the best value or the best performance. And the thing that we hadn't considered until the last year or so is our storage. So I don't really think there's many servers nowadays that you can get provisioned with sort of serial ATA drives. Nowadays you get SSDs, but really there's a massive step change between SATA and SSD drives, but then there's really another step change in performance between SSD and then using NVMe controllers on top of that. So storage is quite an interesting area to look at. So we're starting to profile our servers, and we use a piece of software called Sysbench, and you can look at your CPU or your disk or your RAM and just understand how your server is performing. So these are the stats that we ran across 4 of our machines. So we used to run some of our software in DigitalOcean, we moved it to UpCloud, and then decided that we should spend some money on getting a dedicated machine. So we went for a Intel i9, really top of the spec at that point CPU, and we just got a modest increase in CPU performance compared to using UpCloud. But more recently, we've been using some Ryzen processors, and you can see that there is such a massive change in CPU speed. So this number is effectively giving you, I think, Sysbench tries to calculate prime numbers, and this gives you events per second. So it's quite a nice number that you can use to compare the performance between servers. As well as testing CPU, you can also use it to test your drives. So here's some examples of some commands that you can run to show you your performance of your read and your write performance of your drives. But really, you don't necessarily want to see the commands, you want to see the answers. And really, dedicated machines is where you see the win in terms of storage and performance. So DigitalOcean and UpCloud, the graphs are almost, you can hardly see them. But our 2 dedicated boxes, you can really see the read performance. And actually for our Ryzen box, the write performance is really, really good too. But when you're building websites, it's really your read performance that can make the big difference, especially if you have a large amount of data. Martin's question about the host charge on CPU load. So we typically use DigitalOcean or providers like that, where they just give you a box, and so you can use it however you like. Try not to max it out because you'll get saturation, but you can just try and push it as hard as you can. In the AWS world, we've used a product called Lightsail before, but we just try and like to have a virtual server idea. Again, for the dedicated boxes, pushing as hard as you can, really, try and get the best value for money. So as you can see, we've got the graphs here in terms of performance of the servers, and working in the financial world, I guess the thing that we care about most is the cost. And so with our servers, we don't like to spend too much money on it. As you can see, our DigitalOcean box was £9 a month, and that gave us, I think the CPU numbers may be the easiest number to compare. And you can see that the jump between UpCloud and our first dedicated box really wasn't worth the additional money, unless you were looking at read performance on the drive. But our Ryzen box really makes a difference. So we're paying £25 a month or more for this box, but it gives us so much more performance. And yes, these are dedicated boxes, so you have 100% access to the CPU, which is great. So how do you identify whether your box is going to be good or not? I guess really the answer is you can't, but we use CPUbenchmark.net to try and identify those fast processors. So here we've got a Ryzen 7 5800X, which is our latest machine that we use, and this gives you a CPU mark, and you see here it's 3500 against the i9, which is at the bottom of the chart of the screen grab that I got, of 3166. So there's only 10 or 20% difference in the numbers, but you can really see in the graphs how much of an improvement it has in terms of moving to that Ryzen box. Instead of using Sysbench, a lot of people nowadays use this process called yet another bench script. So this is just a single script that you can execute across your server estate, and then you can get similar numbers to compare how your boxes are performing. And I guess really the question out of all of this is, what impact has this had in terms of the products that we deploy. So after we've done all of the web improvements, after we've done all of our application code improvements, and after we've done all of our database improvements, our setup, we thought, was the best it could be. But actually, when we deployed our new Ryzen box, our website doubled, halved in terms of the time it took to produce our pages. So we might have spent months and months and months of coding. Actually, it would have been easier if we just spent that 25 quid to start with and reduced our page size or our response time. That has been our biggest lesson that we've learned over the last year or two, that actually identifying the servers that execute your code or run your databases can really have a massive impact. Even if you think the boxes you've got at the moment are really, really good, it's definitely worth getting out there and trying to compare other offerings, whether it's from other providers or from your current provider, just to see what there is in terms of performance improvements. And that's really my last slide in terms of database improvement work and server improvement works, and the presentation itself. So hopefully I haven't rambled too much and just kept on talking. Hopefully there's still a few people awake left on the chat, and I hope you found it interesting. And hopefully there's lots of questions where we can now have some interesting debate in terms of observation maybe people have had themselves, or other questions you've got for me in terms of anything I can help you with. I'm definitely more than happy to answer those.
Guys, feel free to lift your mics off and ask any questions. You're getting some claps here. And there was a message to say it'd been really useful. I can't remember where that was. There was a message to say it'd been really useful, and thank you very much. Cool. Any other questions, guys? Oh, here we go.
Yeah, can I ask a question?
Of course.
Yeah, so I'm not a database administrator. I used to be a web developer, and I'm retraining now to do it again. But of course, years ago, you needed a local host to run PHP scripts, etc. So I have a little bit of knowledge from way back 10 years ago. And things have obviously moved on, which is good. Things are much more efficient, it looks like. I was wondering if I'm giving advice to people about hosting their website, when it becomes necessary, especially using things like Laravel, talking security, whether it's a good idea to advise them to go for the cheapest option to begin with when the website's very small, on a shared server. Is that a good thing, or would you recommend hosting a dedicated server?
So from our point of view, we'd definitely recommend using someone like DigitalOcean, because they give you backups by default. Their performance of the boxes are really good compared to their price point. So lots of people use their $5 boxes, and you can get pretty good performance. If not so au fait with Laravel, but for example, if you're using WordPress, then sometimes there are hosts dedicated to looking after those types of environments. So people like WP Engine, or even using people like Cloudflare, they have some WordPress extensions that can help you to optimize your page even when you have a really cheap host. But yeah, I guess in the old world, the idea of shared hosting is you'd have a single server that would be running Apache across thousands of clients. Nowadays, shared hosting is really that you've got your own virtual server, so you can scale that box up just with a couple of button clicks, and you get more performance without having to do anything crazy. So yeah, DigitalOcean or Vultr are great because they currently offer $200 free, so you can almost run your box for a whole year for nothing. Or UpCloud, or if people want to stay within Amazon, then maybe something like Lightsail is really quite a good product. Okay.
And things like Cloudflare, the security system that you were talking about earlier, sorry, optimization system, they're all available on the system. You can pretty much load anything on you want.
Yeah, Cloudflare is great. All you do is, after you've registered your domain name, you just point your DNS servers to Cloudflare, and they look after the rest. And actually, Cloudflare have just recently become a domain registrar, so they're the only company that offers domain registration at wholesale cost. So you can register your .com or .co.uk domain, and you'll be paying what every other big registrar pays, but you don't have to pay any fees on top of that. So yeah, Cloudflare are definitely becoming the one-stop shop for that type of stuff.
Yeah. Okay, thank you.
You're welcome.
Martin's asked a question. So do you have any ongoing regime of monitoring so that you can keep an optimal solution?
Yeah, so I think what's interesting is that there's always going to be times when you release some code that you think is going to make your website faster, but actually has completely the opposite effect. And so, yeah, we use Pingdom or Tideways, and we just leave it running on our servers because they're very good at telling you very quickly what you've deployed has really had a negative impact. So it might be that performance, i.e. the website is still running at exactly the same speed, but your server is working a lot harder to do that. So it's not always the response time that can be impacted. It can be how hard your machine's working too. So yeah, we tend to leave those types of monitoring on. At least then we can prove over time whether we've made improvements or whether the servers are changing in terms of their performance over time. But more importantly, that the code that you've released doesn't have any additional issues with it.
Oh, here we go. Any ELK for monitoring and analysis for web traffic?
What's an ELK? Can anyone Google ELK for me?
ELK. First past the post. Is an acronym for 3 open source projects: Elasticsearch, Logstash, and Kibana.
I don't use any of those products because I try and keep my world very, very simple. But you know, for example, if you're using AWS or DigitalOcean, then they give you server stats built in, so you can use that for monitoring your server performance. And then web traffic, again, you could use something like Pingdom for just monitoring your endpoints and making sure that you've got good coverage across various endpoints is always a good thing to do. But yeah, I've not used Elasticsearch at all.
That's it. I don't think there's any other questions. Anyone else, guys? No, all gone quiet. So, right. Thank you very much, Adam. That pulls us in at 10+7, which is brilliant timing. You got another clap, more claps. Everybody's saying thank you. Oh, thank you, Adam. It's been brilliant. We do record these sessions and we'll pop it onto the website. So it'll be an ongoing resource, which is brilliant. I think that's one of the most useful elements of the ISTN. We've got all of our talks recorded and continue to be useful for people. So that will go on and we'll send you a copy of the recording and we'll give you an access to more events going forward. So guys, if you want to have a look in the meantime, I will just drop in quickly while we are istn.org.uk, just put the link in there. So if you want to have a look at it, anybody, again, if you guys are interested in giving a talk or if you've got another anything specific that you would want to learn, let us know. And other than that, we've got I think the event that I thought was on Thursday is not on Thursday. I think it might have moved to November, so I'm being a bit quiet about that. But there are lots of other events booked for October, and November's schedule will be launched soon. Thank you all for attending, and we will see you at the next talk. Thanks to Adam. Thank you very much, guys. We'll see you soon. Take care.
Thank you. Bye-bye.
Thanks a lot. Bye, guys.